Hello, my name is Brian Noss, and I am a software engineer at an aerospace and defense company specializing in radar installations for civilian and military applications. The problem I've decided to tackle today is to design a scalable microservice-based e-commerce system that can handle dynamic inventory, user recommendations, and real-time payment processing. My design solution overview: I focused on purchases, returns, support, recommendations, and payment processing. Each of these were separated into individual classes that work together to achieve the goal, but do not interconnect and communicate with one another. My problem statement: this system aims to address and improve upon the inadequacies in other e-commerce platforms. By using a dynamic inventory solution, the system can reduce inaccurate inventory counts, remove the need for manual inventory management, and track inventory from multiple sources. Customers must be able to purchase products and process returns through the system. Next, the recommendation engine will provide customers with recommendations that are unique to them and their preferences, giving them better quality search results and helping merchants on the platform to drive sales. Finally, the system will produce payments in real time to help merchants and customers with a seamless experience. This is my use case diagram. This follows the use cases of place order, process return, answer support ticket, recommend product, and process payment. The customer can place an order, and that order would then be sent to the merchant. But that order also initiates the process payment method, which, if approved, will send the payment information and money to the merchant. The customer can also process a return, which will occur in the system. A decision will be made to either approve the return or deny the return, depending on the factors, and that information will be sent back to the customer so they can send the product back to the merchant. Customer service representatives can answer support tickets created by customers, and then the answer to the support ticket is sent to the customer, whether it's feedback or a correction to an issue. There's also another actor in the recommendation engine. This is a non-human action represented by a machine learning algorithm that recommends products based on a customer's past searches and past purchases, and then sends a list of recommended items back to the customer. The activity diagram shows how classes interact and how information moves across the system. The blue dot represents the customer. A customer can search for products, and then this information is sent to the recommendation engine to provide better recommendations in the future and update the user's preferences. Additionally, this is then sent to the inventory system. If the inventory system sees that the product is out of stock, it will then put you back to the search product function, as you cannot complete a transaction for an item that is not available. If the item is available, then the item will be added to the shopping cart, where the user can then place the order and process their payment. If the payment has been denied, then the order is canceled, but if the payment is approved, then it is sent to the merchant to complete the order. The customer can also process a return. From here, the process can either be denied, in which the information is sent back to the customer and the return is not completed, or it will be sent forward to the merchant in order to facilitate the return process. This is the domain model, which is a conceptual model of a system as a whole, and incorporates behavior and data. Our main classes are customer, merchant, customer service representative, and the recommendation engine. The customer contains the information of customer ID, phone number, email address, home address, and payment information. The merchant contains a merchant ID, phone number, email address, and address. The representative has a representative ID, phone number, and email address. And the recommendation engine has the customer ID and the search terms that they use. If a customer searches for a product, the search will then find a product, and that will adjust the inventory if they decide to continue the purchase. This item is then added to the shopping cart, where they can check it out, place the order. The order will then be processed and sent to the merchant. Payment processing is also done at this stage, where it submits the payment to the payment processing class, and then the payment processing network, who will eventually send the money to the merchant if everything clears. The customer can also create a support ticket, which will be assigned to a customer service representative, and then that service representative will answer the ticket, and this will be sent back to the customer for feedback. And finally, the customer can process a return in which all that information is sent to the merchant so that the return can be facilitated. The state chart shows how information moves across the system and how different objects reach different states. For example, a customer can search for a product. That product is then added to the cart. From here, the customer can continue to shop, or they can go to checkout, place their order, and move on. If they decide to keep shopping, then they get sent back to the search products class in order to continue looking for different items. If they choose to check out, they will place their order, which will process their payment. Once their payment is submitted to the processing network, it will either be approved and sent to the merchant along with the order information, or it will be denied and sent back to the customer, informing them of this change. The search products class also sends information to the recommendation engine, which uses it to make lists of recommended items, which are sent to the customer. There is no state here, as this happens regardless, and there is no alternative path. A customer can also process a return, where this then reaches the gate where it's either accepted and the information is sent to the merchant, or it is denied, and once again the information comes back around to the customer to inform them of the decision. Finally, a customer can create a ticket, and that ticket will be answered by a customer service representative. No matter what happens here, the ticket will be answered and sent back to the customer so that they can receive the help they need or the feedback from the ticket. In the component diagram, we can see the system's components and the dependencies of those components. So we can see that the customer logs into the system through the external port, and then they are issued to the customer component. From here, they can enter search terms to search products, or they can initiate the return process for an already existing order. If they continue down the search tree, they will then search for a product. This will go and feed into the recommendation engine, which will then feed into the recommend products class, which will show those recommended items back to the customer. Otherwise, it will be added to the shopping cart, where it will be adjusted for the inventory to ensure everything remains correct. From here, we will check out and head to place order. Once we place the order, we head to the payment processing network, which is an external actor. And then, if that information is all cleared, it is sent to the merchant so that they can receive their money. Additionally, if the customer decides to do a return for an existing order, they will process the return, fill out all the information, and that information will be sent to the merchant to make a decision, either approving or denying the return. This chart also shows which are internal and external to the overall system. For example, we have the web store as one subsystem, the payment processing network, the inventory database, the recommendation engine, which is external as it is a machine learning protocol being run on a different server, and the merchant network and the merchant's computers. For this project, I used the microservices architecture, breaking each subroutine into its own service that is independently deployable, loosely coupled, and easily scalable. This prevents any one system from affecting the rest of the system and should keep everything moving smoothly and operating at peak capacity. I decided this approach was best, as it would allow for every system to work independently and decrease the downtime of the system, because even if one subroutine is down, the project can continue to operate and perform in other capacities while we are waiting for it to be fixed. In my project, I decided to use polymorphism, pure fabrication, low coupling, and a controller pattern. Polymorphism is used to reduce redundancy between the customer class, merchant class, and representative class, as they contain a lot of the same information. Pure fabrication was used for the classes of processing payments, the shopping cart, and the place order class in order to reduce coupling, reduce maintenance, and increase the ease of implementation into the system. Also, this uses the controller pattern, as there are many controllers that act as classes to delegate the work throughout the system. Conclusion. Key takeaway and next step. My key takeaway of this course is software system design is much more complicated and intricate than I originally thought. A good system encompasses a wide variety of patterns and principles that must be implemented in every facet of the design process from the very beginning. This class has helped me to understand how the decisions made throughout the software development lifecycle can have large impacts on the system as a whole, and that going the extra step to ensure work fits these principles can create clean, modular code that is easy to maintain and implement within a larger system. It has definitely helped me to understand how to better develop software, and I've already seen myself being able to make small changes in my workflow in order to better facilitate these changes and make better decisions in my coding processes, especially in the specific cases of better exemplifying object oriented design, such as polymorphism, inheritance, and encapsulation.